So I'm going to try to answer these questions with this video. Finding in chapter 2, it's all about calculating numerical summaries. In chapter 3, we're going to look at shapes and then see how the numerical summaries are related to the shapes and what to decide. So I'll kind of blend this all together, partially into chapter 2, start of chapter 3. So we've got from here on out, or actually starting next week, from here on out, I'm going to ask you to describe distributions. And distributions are described by shape, and they're also described by center and spread. So whenever I ask you to describe a distribution, you want to give it a name, shape, and there's three biggies, and we'll talk about more of those next week, maybe with this video, and then the mean, standard deviation, and or the 5-number summary. So what I did here is I got some data from another textbook that I used to use, and this is the percent of sugar in all these old cereal brands. And we're going to describe this distribution of sugar. Of sugar, right? It is sugar of cereal. So what I'm going to do then I'm going to copy this data because it's in a spreadsheet form. It's a lot of it. I don't want to do this stuff by hand, and I don't want you folks to do it by hand. It's just a few data points, like at the start, those problem set, chapter 2 and the chapter 2 problem set in the book, but just a few of them. Yeah, the essential objectives in the course, you got to do it by hand for small data sets. And really, by small data sets, I mean small data sets. You'll have to do that this week with a homework, maybe with a quiz a little bit. Probably will never ask you to do this by hand again. And when on the final exam, on the first exam, there's going to collect your own data set of 30 items, and I don't want you to do those calculations by hand. I want to use text. That's another reason why I'm making this video. So I'm going to copy that data into my clipboard memory, and then I'm going to point you towards, let's see here. Not here. Let's see, that's my Oxbow side, sorry. So here I am in our course in Canvas. I'm in modules. And if you go to course resources, you see this, just a minute here. I gotta make it here. Thought I had those here. Let me pause this video. Okay, here we go. So in the modules, course resources, that first module, see that online statistical tools web page I've got set up? Here's a whole bunch of applets, calculators that I'm going to point you towards during this course, all right? And one of them that works pretty well is this first one, this one variable statistics in a box plot. And you're learning about box plots in chapter 2, which is good. And actually, this does do box plots. This isn't the one I was thinking of. Just a minute here. Let's do this one. Why not? Let's use this one. What you're going to do is you're going to clear the data for this one. It's the one I was thinking of, but this one does work. I'm going to paste in all that sugar. I'm going to update the box plot. And here it is. So the other thing that's kind of cool about this one, now remember, this is the minimum, first quartiles, median or second quartile, the third quartile, and the maximum value. And then if you click on show statistics, it shows you all those, the 5-number summary. It doesn't show you the mean, does it? Another one I did show that. So here's your 5-number summary, and I don't know, it's okay. Should I use the 5-number summary? Well, to describe this distribution, well, one thing that I do see and do notice about this distribution, this is kind of the chapter 3 stuff. You see how there's kind of the median is not in the middle of the box. And so what we're really seeing here is 25% of the data here is here. 25% of the data is here. So 50% of the data of the cereals have sugar contents between, whatever that number is and whatever that number is. And then the other 50% is spread out. So if we were to look at this would be a big long tail, the tail's there, even that tail is longer than that. The whisker for a box and whisker is longer than that. So this is, I'm seeing this is the right skewed distribution. I'll put this in a histogram. We'll also check that out that way. Another way to do it, or the dot plot if I can find that other applet. And then, so what should be the appropriate measure of center and spread we should be using? We should be using the 5-number summary here, the median, the 5-number summary. If we're looking for outliers, we want to use that 1.5 IQR test to describe outliers. I'm not totally sure there are any outliers here. Would have to do the test to see. And maybe you didn't ask me about that, so I don't want to confuse this. But that's what we would do. And notice I didn't have to do this by hand. I said shape, right skewed. We should use the median and the 5-number summary, or the median and the IQR to talk about center and spread. If you haven't done that MyOpenMath outlier homework, there's like 3 questions on it. It's worth your time to do it. One of them might be wonky. I don't remember if I fixed it or not, where the minimum fence obviously is broken, but I don't know if I fixed that or not. But anyways, that aside, it's worth your time to go do that. So that's what that is. Now let me go find that other applet I was talking about, and then because we can see a lot of things all at once with that one. Let's see here. So I did find it. It's the one here that's called dot plot. I probably ought to add a link to it. So here's the Rossmann chance. I'm going to point you in to spend some time in this on this website and their applets, not necessarily this one towards the end of the course. So this is a 1-variable statistic, descriptive statistics. I'm going to clear the data that's in here and paste in that sugar data again. And when you use the data, and here's a dot plot. It'll even graph add a box plot to it, so you can see how those kind of compare. See how the data is really clumped up here, less than the median, and it's really spread out there. We could even do a histogram. It'll do instead of a dot plot, it'll give us a histogram, and you can see a lot of that data is here, and it's kind of spread out here to the right. You can almost see the tail. I mean, that bump is a little weird, but it does kind of look like a tiny like right skewed. And then if we look at the mean and the median, you see how the mean is to the right of the median, see that's bigger than. So that's another flag that yeah, this is a right skew distribution, because you have those means, you have those high values pulling the mean up away from the median, because you're adding up all the values, dividing by the number of values, whereas the median is just the exact middle. So yeah, this is a right skew distribution, and there's the mean and the median. So we really want to talk about describe this with the median and the 5-number summary. Okay, so that's what the mean that is. Now, what about the standard deviation and the mean? Because and the variance somebody asked about. Let me pause this. I'll come back to another calculator and I'll show you that. So this frequency table and histogram, this is really getting into chapter 3 stuff, but it is pertinent here. So I'm going to clear the data here. It's that same Schodor site. They have some nice calculators. And I'm going to update the data. And there's that kind of like what we were looking at with that Rossmann Chance website, right? What's cool about this website is you can drag this to increase the number of bars and make it look more like what maybe you want it to look like. I mean, is it cheating? I mean, you're trying to lie? Not really. As long as you keep more than 3 boxes or more than 3 bins, or less than 20. See, if you make them too small, it gets kind of weird. That's weird. So we want to try to make them connected, though they don't have to be connected. I don't know if that helps. I don't like that either. But if we come up here, it's a little bit of a wonky set, but it is right skewed based on the position of the mean and the median. So what we can do is we can get. I have more videos about how to use this. Somewhere here they show us a frequency table. Here we go. And they also show us the mean here, the mean and the standard deviation. So the mean is the center of this distribution, not the 50% center, but what describes the center, right? And the standard deviation is a measure of spread, like how is the data spread around that mean? And that's all it is. Now, what's the variance? Well, the variance, some statistical analyses like using variance things to see how the data sets are spread for other reasons, other purposes. For us, the variance is just going to be a way to get the standard deviation. Okay, that's where it happens when you do all the subtractions, square all the differences, add them all up, divide by one less than the number of data pieces. That's the variance. When you take the square root, you get the standard deviation. So there it is for us, a lot less effort, especially when you got how many 49 numbers. I don't want to calculate that by hand. You shouldn't either. So that's all the standard deviation. Standard deviation and the mean are married. We never talk about the median and the standard deviation. We never talk about the mean and the 5-number summary. If you're going to go with a mean, you use the standard deviation to talk about spread. Means is going to be our center, quote unquote, and the standard deviation is the spread. Typically, we use mean and standard deviation for symmetric distributions, specifically normal distributions. You're going to go with this unimodal, one mode, and symmetric. We don't use weird distributions where here, I got a pen here. If we had a distribution that looked like this, right? If we had a distribution that looked like this with some here, it goes down and it increases again. I know that's a lousy histogram, but you see, it dips in the middle and goes back. Kind of a symmetric distribution. If I drew it better, it would look much more symmetric, but that's wonky. I mean, I don't know what we would want to do with that. I mean, you could use the mean and standard deviation, I guess, but it's not really useful. I don't know. Mean standard deviation for symmetric distributions, median 5-number summary for skewed distributions. I would almost lean towards using the mean, the median and the 5-number summary here, but I don't know. I mean, I'd have to see what it did for us. It is a symmetric distribution there. Okay, so I hope this answers your question without getting it too deep in the woods, too much in the weeds. I encourage you to use these applets when you're doing the calculations. They're very useful, and I don't want you to have to do all that stuff by hand. Basically, for the first part of this course, we're just looking at these three, and then we'll start doing some probability after the first exam. Okay, so hopefully, again, I found this modules. Let me clear off that. How do I undo all my? Oh, I don't remember now. I can erase it, I guess. Anyways, here in course resources, and then I have that online tools right there, so we can find them. Okay, give me a yell if you need some help. And if you need me to do a better video, let me know too.